Welcome to AudioDocs by Platform-Engineering-Playbook, where we transform open-source documentation into audio you can learn from anywhere. Each episode aspires to adapt official project docs into digestible audio, explaining concepts clearly using conversational explanations that are easier to absorb on the go. Everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. If you find this useful, please like and subscribe. And if you catch any mistakes, please leave a comment or open a pull request to help make the playbook smarter. The episode transcripts are open source at platform-engineering-playbook.com. Let's get into it.
Stern, multi-pod and multi-container log tailing for Kubernetes, version 1.33.1. Today, we're exploring Stern, a tool that fundamentally changes how you tail logs in Kubernetes. If you've ever found yourself juggling multiple terminal windows, each running kube-control logs on different pods, or trying to debug an issue across pods that keep getting recreated, Stern is about to become essential to your workflow. Let's start with the problem Stern solves. In Kubernetes, pods come and go. A deployment might have 5 replicas, each with its own pod name ending in a random suffix. When you need to see logs from all of them simultaneously, kube-control logs only handles one pod at a time. And when a pod gets deleted and replaced, you lose your log stream and have to start a new kube-control logs command with the new pod name. Stern eliminates this friction entirely. It tails multiple pods simultaneously, automatically adds newly created pods to the stream, removes deleted pods cleanly, and color codes output so you can visually distinguish which logs came from which pod. The basic usage is simple: Stern followed by a pod query. This query is a regular expression, so Stern Nginx would match Nginx-frontend ABC123, Nginx-backend XYZ789, and any other pod containing Nginx in its name. You don't need exact pod names. You don't need to know the random suffixes. Just describe the pattern you want. But Stern goes further. You can also query by Kubernetes resource using the format resource/name. For example, Stern deployment/nginx tails all pods belonging to that deployment. Stern supports pod, replication controller, service, daemon set, deployment, replica set, stateful set, and job resources. This is incredibly powerful because you're expressing intent. Tail the logs for this deployment rather than hunting for specific pod names. Let's talk about containers. When a pod has multiple containers, kube-control logs requires you to specify which container you want. Stern, by default, tails all containers in matching pods. The output includes the container name so you can tell them apart. If you only want specific containers, use the -c flag with a regular expression. For example, Stern Nginx-c app would only show logs from containers matching app. Conversely, you can exclude containers. The -E flag excludes containers matching a pattern. This is particularly useful for filtering out sidecar noise. Running Stern-n staging --exclude container ISSTO proxy followed by a dot tails everything in the staging namespace except ISSTO proxy sidecars. Similarly, you can exclude entire pods with --exclude pod. Debugging an issue and the kube API server logs are drowning out everything else, Stern-end kube system --exclude pod kube API server followed by a dot shows all kube system logs except the API server. Namespaces work exactly as you'd expect. The -n flag specifies a namespace. For multiple namespaces, repeat the flag or use comma-separated values. The -A flag for all namespaces tails across your entire cluster. This is the nuclear option for debugging distributed issues. You can filter by labels with the -L flag. Stern --all namespaces -l run equals nginx tails every nginx pod in your cluster regardless of namespace. Label selectors follow standard Kubernetes syntax, so complex selectors work too. Node filtering is available with --node. If you suspect a node-specific issue, stern --all namespaces -field selector spec.nodename equals kind control plane shows only logs from pods scheduled on that specific node. Now let's discuss output formatting. Stern offers several predefined templates via the -o flag. The default output shows namespace, pod, and container names color-coded for readability. The raw output strips all decoration, giving you just the log messages. This is perfect for piping to tools like JQ when your logs are JSON. The JSON output marshals the complete log struct to JSON, useful for programmatic processing. The XJSON and PXJSON outputs provide extended JSON with colorized names, with the PP variant pretty printing the output. For complete customization, Stern accepts Go templates via the -template flag. The template receives the message, node name, namespace, pod name, container name, labels, and annotations. You can format output however you need. For example, to include the node name in every line, use a template like double curly braces, printf, %s, space, parenthesis, %s slash %s slash %s slash %s, close parenthesis, new line, space dot message, space dot node name, space dot namespace, space dot pod name, space dot container name, close curly braces. Stern provides helper functions within templates. The parse JSON function parses a JSON log message so you can extract specific fields. The try parse JSON function attempts parsing but doesn't fail if the message isn't JSON, perfect for mixed format logs. The level color function colorizes log levels appropriately. Error in red, warning in yellow, and so on.
Time-based filtering is handled by the --since flag. The default is 48 hours, meaning Stern shows logs from the last 2 days. For recent debugging, Stern auth-t-since 15m shows the last 15 minutes of auth-related logs with timestamps. The -t flag adds timestamps, which you'll want for most debugging sessions. The --timezone flag controls timestamp display. By default, timestamps show in your local time zone. Specify a time zone like Asia/Tokyo if your cluster runs in a different region than your terminal. The --tail flag limits initial output. Running stern engine --tail 10 shows only the last 10 lines from each container before streaming new logs. This prevents the initial flood when tailing long-running pods. Setting --tail 0 shows no historical logs, only new ones. The --no-follow flag is crucial for batch processing. Instead of streaming continuously, Stern exits after showing matching logs. Combined with --only log lines and sorting, you can create ordered log views. For example, stern --since equals 5m -no-follow -only log lines -A -t dot pipe sort -k4. This shows all logs from the last 5 minutes across all namespaces sorted by timestamp. For highlighting specific patterns within logs, use -H with a regular expression. The matching text is highlighted in the output, making it easy to spot specific errors or events in a stream of logs. Stern also supports filtering log lines themselves. The -I flag includes only lines matching a pattern. The -E flag excludes lines matching a pattern. These operate on the log content, not pod names, letting you focus on specific messages. Let's discuss configuration. Stern supports a config file at ~.config/stern/config.yaml. Any flag can be set here as a default. For example, if you always want timestamps and a shorter tail, tail, max log requests 999, timestamps short. The max log request setting is important for large clusters. By default, Stern limits concurrent log streams to 50 to prevent overloading your cluster's API server. If you're watching many pods, you may need to increase this. With --no-follow mode, the default drops to 5 since it's a burst operation. You can customize colors for pods and containers via the config file or command line flags. Colors use SGR sequences. For example, pod colors 32, 33, 34, 35, 36, 37 sets green, yellow, blue, magenta, cyan, and white as the color rotation. Container colors can differ from pod colors using container colors.
Installation options are plentiful. Homebrew users, brew install Stern. Crew users, kubectl crew install Stern. Then access it as kubectl Stern. APT, Pacman, ASDF, Winget, and direct binary downloads are all available. Building from source is straightforward. Go install github.com/stern/stern at latest. For container environments, Stern publishes images at ghcro/stern/stern. If running against a local cluster like Minikube, you'll need to mount your kube config and credentials appropriately. Running Stern inside Kubernetes pods requires RBAC permissions. Create a cluster role with get, watch, and list verbs on pods and pods/log resources. Then bind it to your service account. Shell completion is available for Bash, Z-Shell, and Fish. Run stern-completion followed by your shell name to output the completion script. Source this in your shell configuration. Stern's completion is dynamic. It will tab complete namespace names, context names, and even resource queries like deployment/. Some practical tips for your workflow. First, alias frequently used commands. Maybe alias KL equals stern-a for quick all namespace tailing. Second, combine Stern with kubectx and kubeNS. Switch context with kubectx, switch namespace with kubeNS, then Stern without namespace flags uses your current context. Third, for incident response, start broad, then narrow. Begin with stern-a, followed by an error pattern to find where issues are occurring. Then add namespace and pod filters to zoom in. Fourth, pipe to grep, JQ, or other tools as needed. Stern's raw output mode integrates well with text processing pipelines. Fifth, for production systems, be mindful of API server load. Many concurrent log streams, especially with --all namespaces, generate significant traffic. Use --max log requests to limit concurrency and --since to reduce the time window. Let's summarize what we've covered. Stern tails logs from multiple pods and containers simultaneously using regex or resource queries. It automatically detects new and deleted pods, maintaining a live view of your workload. Output is color-coded by default, with extensive customization available through templates. Filtering works at the pod level, container level, and logline level. Configuration via config file lets you set sensible defaults for your environment. The key takeaway: Kubernetes log debugging doesn't have to mean hunting pod names and juggling terminals. Stern gives you a unified, real-time view across pods, containers, and namespaces. Install it, add it to your debugging toolkit, and your Kubernetes observability immediately becomes more effective. For more information, visit the GitHub repository at github.com/stern/stern. That's Stern version 1.33.1.
That's it for this episode of AudioDocs by Platform Engineering Playbook. If you spotted any issues with these AudioDocs, leave a comment or open a pull request. Every script and transcript lives out in the open at platform-engineering-playbook.com. Finally, if you found this valuable, consider subscribing and giving this video a thumbs up to help others discover our content. Thanks for listening, and see you next time inside the Platform Engineering Playbook.